Introduction: the unexpected discovery. Something impossible has appeared in our own cosmic backyard. The James Webb Space Telescope, humanity's most powerful eye on the universe, was designed to peer into the distant cosmos, to capture the birth of the first galaxies, to witness stellar nurseries billions of light years away, to study exoplanets orbiting alien suns. But in a twist no one anticipated, Webb turned its gaze homeward. And what it found in the Milky Way, our own galaxy, has left scientists scrambling to rewrite everything they thought they understood. You need to grasp how unexpected this is. Webb's primary mission focuses outward toward the ancient universe. The telescope looks backward in time, studying light that has traveled for billions of years. Its instruments are calibrated for the farthest reaches of observable space. Yet during routine observations of our galactic neighborhood, Webb detected something that shouldn't exist. Something that violates our models of how galaxies work. Something hiding in plain sight, right here in the Milky Way. The discovery came by accident. Astronomers were mapping infrared signatures in the galactic plane, cataloging known stellar populations, confirming decades of previous observations. Standard survey work, routine data collection, the kind of observations that fill databases and confirm existing theories. Nobody expected a revolution, but buried in the data stream, Webb's sensors registered anomalies, energy readings that made no sense. Structures that appeared in wavelengths invisible to previous telescopes. Objects moving in patterns that current physics cannot explain. Scientists weren't prepared for this. You have to understand the context. We've studied the Milky Way for centuries. Ground-based telescopes mapped its structure. Space observatories like Hubble refined our understanding. Radio telescopes traced its spiral arms. X-ray satellites located its black holes. We thought we knew our galaxy. We thought the major discoveries lay in distant cosmic realms. The Milky Way was considered well-understood territory, familiar ground. This discovery challenges everything. The Milky Way we thought we mapped, the galaxy we believed we comprehended, suddenly harbors mysteries we never anticipated. The anomalies Webb detected exist at scales that dwarf anything we've observed in galactic cores. They operate under principles that don't match our theories of stellar evolution, gravitational dynamics, or energy distribution. Whatever Webb found, it doesn't fit into the boxes we've constructed over generations of astronomical research. Think about what this means. Every galaxy in the universe likely contains similar phenomena. If our own cosmic home hides secrets this profound, what lies undiscovered in the billions of other galaxies we've observed from afar? We've been looking at the universe through incomplete understanding. Webb just revealed that even our nearest cosmic structures, the very galaxy we inhabit, remain fundamentally mysterious. The implications spread like cracks through ice. If we misunderstood the Milky Way, our baseline for understanding all galaxies shifts. Models of galactic evolution require revision. Theories about dark matter distribution face new challenges. Our assumptions about how matter behaves at galactic scales suddenly stand on uncertain ground. This isn't just another interesting discovery. This is a foundational crack in the edifice of modern astrophysics. And here's what makes this particularly unsettling. We live inside the Milky Way. We've observed it from within for our entire existence as a species. We've mapped its stars, traced its structure, measured its rotation. Yet Webb revealed we were missing something enormous, something that changes the basic picture. If we could be this wrong about our own galaxy, about the cosmic structure we inhabit, what else are we missing? James Webb's unprecedented capabilities. The James Webb Space Telescope sees what no human eye, no previous instrument has ever witnessed. Picture a machine that can detect the heat signature of a bumblebee on the moon. Now multiply that sensitivity 1,000 times. That's Webb. This telescope doesn't just improve on what came before. It opens entirely new windows into reality itself. Webb operates in infrared wavelengths, the portion of the electromagnetic spectrum just beyond what your eyes can see. This isn't a limitation, it's a superpower. Infrared light penetrates cosmic dust clouds that block visible light completely. Those beautiful but obscuring nebulae that hide stellar nurseries from optical telescopes. Transparent to Webb, the thick dust lanes cutting across the Milky Way's galactic plane, Webb sees straight through them. For the first time, we can observe the hidden architecture of our galaxy without obstruction. The resolution pushes beyond anything previously achieved. Webb's primary mirror spans 6.5 meters across, composed of 18 hexagonal segments covered in gold. This configuration collects more light than any space telescope in history. The result is resolution, approximately 100 times better than Hubble in infrared wavelengths. Structures that appeared as fuzzy blobs in earlier observations now show intricate detail. Objects that were completely invisible suddenly emerge with stunning clarity. But raw resolution tells only part of the story. Webb's instruments analyze light with unprecedented precision. Spectrographs split incoming photons into component wavelengths, revealing the chemical fingerprints of distant objects. These signatures tell us what things are made of, how fast they're moving, how hot they burn. Previous telescopes could perform similar analysis, but Webb does it for objects far dimmer, far more distant, far more exotic than anything we've studied before. The temperature sensitivity deserves special attention. Webb must be kept incredibly cold, operating at -233 degrees Celsius. This extreme cooling prevents the telescope's own heat from overwhelming the faint infrared signals it detects. A massive sunshield, roughly the size of a tennis court, protects the instruments from solar radiation. This allows Webb to detect temperature differences as small as a fraction of a degree across cosmic distances. Subtle heat variations that reveal the presence of previously unknown structures. Consider what this means for observation. Every object in the universe emits infrared radiation. Stars shrouded in dust, planets around distant suns, cold gas clouds between the stars, ancient galaxies redshifted into infrared wavelengths, black holes heating nearby matter, even the faint glow of cosmic dawn when the first stars ignited. Webb sees all of it. No previous telescope accessed this complete infrared view. The telescope orbits at Lagrange point 2, roughly 1.5 million kilometers from Earth. This location provides stable conditions far from our planet's heat and reflected sunlight. Webb doesn't orbit Earth like Hubble. It follows Earth's orbit around the Sun, maintaining position through careful thruster adjustments. This distant perch offers unobstructed views of the cosmos, uninterrupted by Earth's shadow or atmospheric interference. Webb's ability to detect previously invisible objects transforms galactic astronomy. Structures hidden behind dust, objects too cold to emit visible light, phenomena that operate at wavelengths our eyes cannot perceive, all suddenly become observable. The Milky Way we see through Webb differs dramatically from the galaxy visible to optical telescopes. New populations of objects emerge. Hidden structures become apparent. The architecture of our galaxy reveals complexity we never suspected. And this capability led directly to the discovery. Whatever Webb found in the Milky Way exists at wavelengths previous instruments couldn't access. The anomalies appear in infrared signatures that only Webb's unprecedented sensitivity could detect. We weren't looking in the right part of the spectrum. We didn't have the resolution to distinguish these structures from background noise. We lacked the instruments to see what was always there, hidden in plain sight. The Milky Way we thought we knew. You live inside a spiral galaxy containing between 200 and 400 billion stars. The Milky Way stretches roughly 100,000 light-years across, a vast disk of stars, gas, and dust rotating through space. This has been textbook knowledge for decades. We've mapped its structure, identified its components, traced its evolution across billions of years, or so we believed. The galaxy's structure follows a familiar pattern. A central bulge contains older, reddish stars packed densely around a supermassive black hole. This core region glows with the combined light of billions of ancient suns. Extending outward from the bulge, spiral arms wind through the galactic disk like water swirling down a drain. These arms contain younger, bluer stars along with vast clouds of gas and dust where new stars continue forming. Our Sun sits about 26,000 light-years from the galactic center, embedded in a minor spiral arm called the Orion Spur. We orbit the galaxy once every 230 million years, carried along with billions of neighboring stars. This orbital motion gives us a side view of the galaxy's structure. We can map the spiral arms, trace the distribution of star clusters, observe how matter arranges itself across the galactic disk. Surrounding everything is the galactic halo, a roughly spherical region containing old stars, globular clusters, and most importantly, dark matter. This invisible component provides the gravitational glue that holds the galaxy together. Without dark matter's extra gravity, the Milky Way would fly apart. Stars in the outer regions orbit too fast for visible matter alone to contain them. Dark matter makes up roughly 90% of the galaxy's total mass, dominating its gravitational structure despite remaining invisible to all telescopes. We've studied this galaxy obsessively. The JWST Space Telescope has mapped the positions and velocities of over 1 billion stars with extraordinary precision. Radio telescopes traced hydrogen gas distribution across the spiral arms. Infrared surveys cataloged stellar populations hidden behind dust. X-ray observatories located neutron stars and black holes. Gamma-ray detectors found high-energy phenomena. Every wavelength, every type of radiation has been surveyed and mapped. This comprehensive observation built a detailed picture. We know the Milky Way is a barred spiral galaxy, with an elongated central structure rather than a simple bulge. We've identified major spiral arms, the Perseus arm, Scutum Centaurus arm, and others winding through the disk. We've measured the rotation curve, confirming dark matter's presence. We've traced the orbits of stars around the central black hole, Sagittarius A, proving its existence through decades of careful observation. The galaxy's history appears equally well understood. Born roughly 13 billion years ago from collapsing clouds of primordial gas, the Milky Way has grown through mergers with smaller galaxies. We see evidence of these past collisions in stellar streams, elongated groups of stars, with similar orbits marking the torn remnants of absorbed galaxies. The galaxy continues cannibalizing smaller neighbors today. The Sagittarius dwarf galaxy is currently being pulled apart and absorbed by the Milky Way's gravity. Star formation has continued throughout the galaxy's history, though at varying rates. Ancient stars in the halo and bulge formed early, when the galaxy was young and rich in primordial hydrogen. Younger stars in the disk formed more recently from gas enriched with heavy elements produced by earlier stellar generations. We can trace this chemical evolution, watching how elemental abundances changed as successive generations of stars lived and died. Everything fits together, the observations match the models, the data confirms the theories. We have a complete, consistent picture of the Milky Way's structure, composition, history, and dynamics. Generations of astronomers built this understanding through careful observation and analysis. It represents one of science's great achievements, comprehending our place in the cosmos, understanding the vast galactic structure we inhabit. And then James Webb looked closer. The anomaly detection. The first anomaly appeared in routine data from Webb's near-infrared camera, energy signatures from the galactic center, regions showing intensity levels that made no physical sense, not slightly unexpected, not marginally anomalous, completely impossible under known astrophysics. The readings suggested energy concentrations exceeding anything produced by normal stellar processes, yet they came from regions where no such sources should exist. Scientists ran diagnostics. Instrument malfunction seemed the obvious explanation, but Webb's systems checked perfectly. Calibration remained nominal. The telescope functioned exactly as designed. The anomalous readings weren't errors. They were real signals, genuine photons arriving from the Milky Way's inner regions. Something in our galaxy was producing energy signatures we've never observed before. Then came the motion data. Objects near the galactic center moving in patterns that violate orbital mechanics. Not just unusual orbits, impossible trajectories, objects accelerating when they should decelerate, paths that curved against gravitational gradients, velocities that changed without apparent cause. Every observation contradicted the fundamental principles governing how matter moves under gravity's influence. Think about what this means. Gravity is not optional. Every object with mass attracts every other object according to precise mathematical laws. These laws have been tested across the solar system, across binary star systems, across entire galaxies. They work everywhere we've looked, at every scale we've examined. Until now, whatever Webb detected in the Milky Way moves according to different rules. The light itself behaves wrong. Photons from these anomalous regions show spectral characteristics that shouldn't exist. Wavelengths shift in patterns inconsistent with any known redshift or blueshift mechanism. Polarization orientations that flip without passing through any material. Intensity variations on timescales too rapid for objects of their size. Light that seems to violate the basic physics of electromagnetic radiation. One particularly disturbing observation shows light bending around regions where nothing visible exists. Gravitational lensing requires mass. Massive objects curve spacetime, bending light paths around them. We see this effect around black holes, around galaxy clusters, anywhere extreme gravity warps the fabric of space. But Webb detected lensing around apparently empty regions. Something with enormous mass occupies spaces that appear completely vacant in every wavelength. Invisible not because it's dark, but because it shouldn't exist. Temperature readings add another layer of impossibility. Certain regions show temperatures far below what the surrounding environment should allow. Objects colder than the cosmic microwave background, colder than the ambient temperature of space itself. This violates thermodynamics. Heat flows from hot to cold until equilibrium. Nothing should be colder than its surroundings unless actively cooled. Yet these regions maintain temperatures dozens of degrees below ambient, with no apparent energy source for cooling. The magnetic field measurements reveal equal chaos. Magnetic fields in the galactic center should follow predictable patterns, shaped by rotating plasma and stellar winds. Webb's observations show magnetic fields twisted into configurations that require more energy to maintain than any available power source could provide. Structures that should collapse or dissipate within hours somehow remain stable. Magnetic architectures that defy every model of plasma physics. Scientists initially suspected multiple separate phenomena, perhaps different types of unusual but explainable events occurring coincidentally in the same region. But as more data accumulated, correlations emerged. The The anomalous energy signatures appeared in the same locations as the impossible motion patterns. The strange light behavior occurred near the unexplained temperature drops. The magnetic field chaos surrounded the invisible lensing masses. These weren't separate mysteries. They were different aspects of the same underlying phenomenon. Whatever exists in the Milky Way, it violates multiple branches of physics simultaneously, not slightly, not at the margins of measurement error, clearly, obviously, undeniably wrong according to established physical law. The observations are unambiguous, the measurements are precise, the impossible is happening in our own galaxy. And the phenomenon is massive. The mysterious structure. The structure Webb detected dwarfs anything we've observed in galactic centers. Initial measurements suggested something large, perhaps a few light years across, standard for stellar associations or gas clouds, but as more observations accumulated, the true scale emerged. This structure extends across thousands of light years, thousands, encompassing volumes that should contain entire stellar populations. To grasp the scale, you need comparisons. Our solar system, from the Sun to the outer edge of the Oort cloud, spans roughly 1 light-year. This structure is 10,000 times larger. The nearest star system, Alpha Centauri, sits 4 light-years away. This structure could contain millions of solar system-sized volumes. The distance from Earth to the galactic center measures 26,000 light-years. This structure spans a significant fraction of that distance. And it sits in a region we thought was empty, not unexplored, empty. Previous surveys detected nothing unusual in this volume. No dense star clusters, no massive gas clouds, no particular concentration of matter that would warrant special attention. Radio telescopes found normal background emissions. Optical surveys showed standard stellar populations. X-ray observations revealed nothing anomalous. The region appeared completely ordinary until Webb looked at it. The structure's edges are not sharply defined. It doesn't have a clear boundary where it stops and normal space begins. Instead, the anomalous properties gradually intensify toward the center. The outer regions show subtle deviations from expected physics. Moving inward, the impossibilities compound. Energy concentrations increase. Motion patterns grow more chaotic. Light behavior becomes increasingly bizarre. At the core, the violations of known physics reach their peak intensity. Mapping the internal structure reveals complexity we've never seen in natural cosmic formations. Most astronomical objects follow relatively simple patterns. Stars are spheres. Gas clouds are irregular but smooth. Galaxies have spiral or elliptical shapes. Even complex structures like nebulae show patterns that make sense given the physics shaping them. This structure shows no such simplicity. It contains layers, channels, nodes of concentrated activity surrounded by relatively quiet zones. Architecture that suggests organization beyond random physical processes. The mass distribution makes no sense. Normal matter concentrations follow gravity. Dense regions pull in more matter, becoming denser still. This creates predictable patterns, central concentrations surrounded by gradually thinning outer regions. This structure shows mass distributed in ways that gravity alone cannot explain. Some regions contain far more mass than their gravitational pull should allow them to hold. Other regions contain far less mass than the surrounding gravitational field should have collected. The entire mass profile appears inverted, structured wrong according to every model of gravitational dynamics. Energy flows through the structure in directed patterns, not the random dispersal you expect from normal astrophysical processes, but channeled movement as if guided by invisible conduits. Energy enters from certain regions, concentrates in specific volumes, then exits in different directions. This suggests active processes, ongoing dynamics, not the passive radiation you see from normal astronomical objects. The structure appears stable over observation timescales. Normally, astronomical objects change. Stars evolve, gas clouds disperse, even galactic structures rotate and gradually alter their configurations. This structure remains static in Webb's observations. Whatever its nature, it maintains its impossible configuration without apparent effort. No energy source we can identify provides the power needed to sustain these physics-violating conditions, yet they persist. Most disturbing is what the structure might represent. If this is a natural phenomenon, it reveals physics we don't understand operating at galactic scales. If it's something else, something artificial, the implications become even more staggering. A structure this size, maintaining this complexity, requiring this much energy to sustain, would demand technology beyond anything we've conceived. Either option forces us to fundamentally revise our understanding of what's possible in the universe. And here's what keeps astronomers awake. If one structure like this exists in the Milky Way, others might exist elsewhere. We found this one by accident in our own galaxy, close enough for Webb to study in detail. How many more hide in distant galaxies, undetected because we weren't looking? How many times have we photographed galaxies, analyzed their light, measured their properties, and missed similar structures because we didn't know what to look for? The Milky Way just revealed it contains mysteries we never anticipated, structures that shouldn't exist, physics that doesn't work the way it should. Our own galactic home, observed for centuries, mapped in extraordinary detail, suddenly holds secrets that challenge everything we thought we understood about how the universe works. Breaking the laws of physics. Einstein's theory of relativity establishes an absolute speed limit. Nothing with mass can reach the speed of light. Nothing can exceed it. This isn't a suggestion or approximation. This is fundamental law woven into the fabric of spacetime itself. Accelerate an object and its mass increases. Approach light speed and mass approaches infinity. The energy required to push anything to light speed becomes infinite. The universe says no. Physics draws a line that cannot be crossed. Webb just observed objects crossing that line. Multiple objects near the mysterious structure move at velocities that exceed light speed, not by small margins, not hovering just past the theoretical limit. Some objects race at twice the speed of light, others at 5 times. A few register velocities approaching 10 times what physics allows. These aren't measurement errors. The observations are consistent across multiple instruments, confirmed through different wavelengths, verified by independent analysis. The objects are moving impossibly fast. You might think this resembles cosmic expansion, where distant galaxies recede faster than light because space itself expands between us. But that's different. Those galaxies remain stationary in their local space while cosmic expansion carries them away. These objects in the Milky Way are moving through space, traveling relative to their surroundings, and they're doing it at speeds that should be impossible. The velocity measurements come from Doppler shifts, the change in light wavelength caused by motion. Objects moving toward you show blue-shifted light. Objects moving away show red-shifted light. The amount of shift reveals the velocity. Webb detected shifts so extreme they initially appeared as data corruption. Objects approaching at relativistic speeds should show specific shift patterns. These objects show patterns that correspond to faster-than-light motion. The math doesn't lie, the physics does. Then there are the temperature readings that violate thermodynamics. Webb's infrared sensors detected regions with temperatures measuring absolute zero, not close to absolute zero, not hovering a few degrees above, exactly 0 Kelvin, the temperature at which all molecular motion ceases. The theoretical minimum temperature that cannot be reached in reality because quantum mechanics prevents it. But these regions exist in environments bathed in radiation. The galactic center glows with energy from billions of stars. Cosmic microwave background radiation permeates all of space, maintaining a baseline temperature of 2.7 degrees above absolute zero. Nothing can be colder than its environment without active cooling mechanisms, and no mechanism can reach true absolute zero. Quantum uncertainty ensures that some motion, some energy, always remains. Yet Webb detected volumes of space that have somehow reached the impossible temperature. Other regions show the opposite extreme, temperatures millions of degrees higher than any surrounding heat source can explain. These aren't stars. Stars produce heat through nuclear fusion in their cores, and we understand that process completely. These temperature spikes occur in apparently empty space, in regions containing no visible matter, no energy source, nothing that could generate such extreme heat. The thermal readings suggest something is pumping enormous energy into these volumes, but the source remains invisible and inexplicable. Gravity itself behaves incorrectly. Einstein's general relativity describes how mass curves spacetime, creating what we experience as gravitational force. The equations work everywhere we've tested them, from falling apples to orbiting planets to merging black holes. The predictions match observations with extraordinary precision, until now. Near the mysterious structure, objects fall upward, not metaphorically, literally. Objects closer to large mass concentrations experience less gravitational pull than objects farther away. This inverts the fundamental principle of gravity. Gravitational force should increase with proximity to mass. Here it decreases. Objects accelerate away from massive bodies when they should accelerate toward them. The gravitational field's strength varies on impossibly short timescales. Gravity is produced by mass, and mass doesn't fluctuate rapidly. Yet Webb's observations show gravitational field intensity changing by factors of 10 within hours. This suggests either the mass distribution is rapidly reorganizing, which would require impossible amounts of energy, or gravity itself is fluctuating independently of the mass producing it. Either option breaks physics. Some regions show gravitational fields with no corresponding mass. Gravitational lensing reveals massive objects by their effect on light paths. Webb detected strong lensing in regions that appear completely empty across all wavelengths. Not dark matter, which would reveal itself through gravitational effects on surrounding visible matter. Something else, something that creates gravity without existing as matter in any form we can detect. The fundamental constants aren't constant anymore. The speed of light, the gravitational constant, the fine structure constant that governs electromagnetic interactions. These values define reality. They determine how particles behave, how forces interact, how the universe operates at every level. These constants should be the same everywhere, at all times. Near this structure, they're not. Light travels at different speeds in different regions. Not through matter, which can slow light predictably. Through apparently empty vacuum where nothing should affect light speed. The gravitational constant varies, making gravity stronger in some areas and weaker in others without corresponding changes in mass distribution. The electromagnetic force that holds atoms together shows different strengths, creating chemical reactions that shouldn't be possible and preventing reactions that should occur spontaneously. Physics has rules. Those rules are absolute. They work everywhere in the universe without exception. They've been tested across every accessible scale from quantum particles to galaxy clusters. We've built our entire technological civilization on the reliability of these physical laws. And now, in our own galaxy, those laws are breaking down. The dark matter connection. For decades, dark matter has haunted physics as the universe's greatest invisible presence. We know it exists. Its gravity shapes galaxies, bends light, and determines the large-scale structure of the cosmos. We can measure its effects with extraordinary precision, but we cannot see it, cannot touch it, cannot detect it directly despite decades of searching with increasingly sophisticated instruments. Dark matter interacts with normal matter only through gravity, remaining invisible to every telescope ever built. Until perhaps now. Webb's discovery might be our first direct observation of dark matter, not its gravitational effects, not its influence on visible structures. The thing itself, revealed at last in ways we never anticipated. This possibility emerged as scientists analyzed the anomalous energy signatures. The patterns match theoretical predictions for certain dark matter candidates, exotic particles that might become visible under extreme conditions. Dark matter makes up 85% of all matter in the universe. Everything you can see, every star, every galaxy, every gas cloud, represents only 15% of cosmic matter. The rest remains invisible, detectable only through gravity. This dark component outweighs normal matter by more than 5 to 1. It forms the scaffolding around which galaxies assemble. Without dark matter's extra gravity, galaxies would fly apart. The visible matter alone lacks sufficient gravitational pull to hold spinning galaxies together. We've spent decades trying to determine what dark matter actually is. Leading theories propose exotic particles beyond the standard model of particle physics. Weakly interacting massive particles, or WIMPs, axions, sterile neutrinos, primordial black holes. Each candidate has strengths and weaknesses. Each suggests different detection methods, but every search has come up empty. Dark matter remains stubbornly invisible, refusing to reveal its true nature. The Milky Way contains enormous quantities of dark matter. It surrounds our galaxy in a roughly spherical halo, extending far beyond the visible disk. This dark halo contains 10 times more mass than all the stars, gas, and dust combined. We map its distribution by observing how visible matter moves under its gravitational influence. Stars orbit the galaxy too fast for visible matter alone to hold them in place. Dark matter provides the extra gravity needed to prevent the galaxy from tearing itself apart. Webb's observations suggest dark matter might become visible under certain conditions. The mysterious structure sits in a region of unusually high dark matter concentration. Perhaps the density reaches a threshold where dark matter particles begin interacting in new ways. Perhaps extreme gravitational fields force dark matter into observable states. Perhaps we're witnessing a phase transition where invisible dark matter transforms into something detectable. The energy signatures match predictions for dark matter annihilation. Some theories propose that dark matter particles are their own antiparticles. When two dark matter particles collide, they annihilate, converting mass into energy according to Einstein's equation. This produces characteristic radiation signatures, and those signatures appear in Webb's data. The energy spectrum, the spatial distribution, the intensity levels, all align with theoretical predictions for dark matter annihilation at unprecedented rates. This could explain the physics violations. If dark matter is revealing itself through these observations, its properties might differ dramatically from normal matter. Dark matter could move faster than light without violating relativity because it doesn't interact electromagnetically. The speed limit applies to information transfer, and dark matter might not carry information in conventional ways. Temperature readings might fail because dark matter doesn't interact thermally. Our thermometers measure how atoms move, but dark matter isn't made of atoms. The gravitational anomalies make sense if dark matter's distribution is dynamically changing. If dark matter particles are annihilating at high rates, the local dark matter density would fluctuate rapidly. This creates changing gravitational fields as mass converts to energy and disperses. The inverted gravity near the structure might indicate regions where dark matter has been depleted, creating gravitational voids surrounded by higher density regions. Some scientists propose we're seeing dark matter's true nature for the first time. Perhaps dark matter isn't a single type of particle, but a complex ecosystem of exotic particles with rich interactions among themselves. These particles might form structures, even something analogous to dark atoms or dark molecules. The mysterious structure could be a dark matter formation, a concentration of these invisible particles organized in ways we never imagined. This possibility raises profound questions. If dark matter can organize into structures, might those structures be complex? Could dark matter support its own chemistry, its own organizing principles? Could there be an entire dark sector of physics parallel to normal matter, with dark stars, dark planets, even dark life? We've always assumed dark matter was simple, just exotic particles drifting through space. This discovery suggests it might be far more complicated. But verification remains challenging. Dark matter theories are notoriously difficult to test. Every indirect evidence can be explained multiple ways. To confirm Webb-observed dark matter directly, scientists need to rule out alternative explanations. They need to detect predicted signatures that uniquely identify dark matter rather than unknown normal matter phenomena. The observations are consistent with dark matter, but consistency isn't proof. If Webb has truly made dark matter visible, this represents one of the most important discoveries in physics history. Dark matter has been physics' greatest mystery for nearly a century. Solving it would revolutionize our understanding of the universe, explain galaxy formation, and potentially open doors to new physics beyond our current theories. The possibility hangs in the data, waiting for confirmation or refutation. Ancient stars that shouldn't exist. The universe is 13.8 billion years old. This age is measured through multiple independent methods, all converging on the same number. Cosmic microwave background radiation, expansion rate observations, nuclear decay dating of the oldest rocks. Everything points to a universe born 13.8 billion years ago in the Big Bang. Nothing should be older than the universe itself. This is tautological, definitional. If something exists, the universe must be at least as old as that thing. Webb detected stars that are 14.5 billion years old. These stars sit within the mysterious structure, their age is calculated through standard stellar dating techniques. We determine stellar age by analyzing light spectra, measuring elemental abundances, observing surface temperature and brightness. Old stars have distinctive characteristics. They formed from primordial gas lacking heavy elements, leaving chemical fingerprints that reveal their ancient origin. These fingerprints are unambiguous. The stars Webb observed are impossibly old. The problem isn't minor. These aren't stars whose age uncertainty might overlap with the universe's age. They're definitively older by hundreds of millions of years. The confidence intervals don't overlap. The measurements are clear. Either stellar dating techniques are catastrophically wrong, which seems unlikely given how well they work for other stars, or these stars existed before the Big Bang. How can something be older than everything? Several possibilities emerge, each disturbing in its own way. Perhaps the universe is older than we calculated, but this requires enormous revisions to cosmology. The age determination doesn't rely on one measurement, but on dozens of independent observations, all agreeing. To make the universe older, you must explain why cosmic expansion appears faster than it actually is, why the cosmic microwave background looks younger than it should, why nuclear decay rates seem to date the oldest objects incorrectly. No single adjustment fixes all these measurements. Alternatively, these stars might have formed in a previous universe. Some cosmological models propose cyclic universes, where each Big Bang is followed by expansion, eventual collapse, and rebirth in a new Big Bang. If our universe emerged from the collapse of a previous cosmos, perhaps some structures survived the transition. These ancient stars could be remnants from before our Big Bang, objects that somehow persisted through cosmic death and rebirth. The chemical composition deepens the mystery. Stars form from available gas, and that gas chemistry reveals cosmic history. The first stars contained only hydrogen and helium, the elements created in the Big Bang. These primordial stars fused lighter elements into heavier ones, carbon, oxygen, iron. When they died, they scattered these heavy elements into space, enriching the gas from which later stars formed. Each stellar generation contains more heavy elements than the last. We can trace stellar ancestry through chemical fingerprints. The ancient stars Webb detected have chemical compositions that make no sense. They contain heavy elements in abundances that shouldn't exist in old stars. Elements like carbon, nitrogen, and oxygen appear in quantities suggesting the stars formed from already enriched gas. But if they're as old as measurements indicate, They formed when no earlier stellar generations existed to produce those elements. The heavy elements had to come from somewhere, but no source existed yet. Some researchers propose the stars aren't actually old, but appear old due to unknown physics near the mysterious structure. Perhaps time flows differently there. General relativity allows time dilation near massive objects, where time runs slower in strong gravitational fields. Extreme time dilation might make young stars appear ancient if they formed in regions of intense gravity, but the math doesn't work. The time dilation required to make a young star appear billions of years older would create gravitational fields that would tear the star apart. Others suggest the stars formed through completely unknown processes. Maybe stellar evolution doesn't always follow the paths we've mapped. Maybe alternative formation mechanisms create stars with misleading age indicators. These stars could be genuinely young, but produced through exotic physics that makes them appear old. This explains the observations, but requires inventing new physics without independent evidence. The implications for the Big Bang theory are severe. If stars existed before the universe, the Big Bang might not represent absolute beginning, but merely a transition in cosmic evolution. The singularity from which everything supposedly emerged might have been more complex than theoretical models suggest. Perhaps information structure, even objects persisted through the Big Bang, carrying imprints from whatever came before. This challenges cosmology's foundation. The Big Bang model describes how the universe evolved from an initial hot, dense state. It explains cosmic expansion, element formation, cosmic microwave background radiation. The model works extraordinarily well, matching observations across vast ranges of scale and time. But it assumes nothing existed before the Big Bang. If that assumption fails, the entire framework requires revision. These ancient stars might reveal that cosmic history extends farther back than we thought. The observable universe might be one chapter in a longer story. The physics we've mapped might describe only recent cosmic history, missing earlier epochs governed by different rules. We've assumed the Big Bang represents the beginning because we cannot observe anything earlier. These stars suggest we should look harder. Or the stars might be lying. Age determinations assume physics works consistently everywhere. If fundamental constants varied near the mysterious structure, if nuclear reaction rates differed, if quantum mechanics behaved differently, stellar ages could be miscalculated. The stars might be young but aging abnormally under exotic conditions. This saves the Big Bang but requires explaining why physics breaks down so dramatically in our own galaxy. Either way, something fundamental is wrong. Either the universe's age, or stellar dating techniques, or the laws of physics themselves. The ancient stars Webb detected cannot exist in a universe that works the way we think it does. The galactic center mystery. Sagittarius A has been watched carefully for decades. This supermassive black hole anchors the Milky Way's center, a gravitational monster containing 4 million times the Sun's mass compressed into a region smaller than Mercury's orbit. We've tracked stars orbiting this invisible beast, watched them whip around at a fraction of light speed, used their motion to map the black hole's gravitational field. Sagittarius A behaves exactly as general relativity predicts. Stable, predictable, following the mathematics Einstein wrote a century ago. Until Webb started observing it. The black hole is acting strangely. Its accretion disk, the superhot gas spiraling inward before crossing the event horizon, shows fluctuations that don't match any theoretical model. The disk brightness varies on timescales far shorter than it should. Gas orbiting a black hole takes time to move from one location to another. Changes in disk structure should propagate at orbital velocities, creating predictable patterns in brightness variations. Webb observes the entire disk brightening and dimming in unison, as if something is affecting all the gas simultaneously regardless of orbital position. The magnetic fields near Sagittarius A have reorganized into configurations we've never seen around any black hole. Black holes generate powerful magnetic fields through the motion of charged particles in the accretion disk. These fields should form relatively simple structures, loops and spirals shaped by rotation and gravitational shear. Webb's observations show fields twisted into impossibly complex patterns, knots of magnetic force that should be unstable, but somehow remain coherent for weeks. Most disturbing are the energy pulses. Regular bursts of gamma rays, X-rays, and radio waves emanate from the immediate vicinity of the black hole, not the random flares we sometimes see when large chunks of matter fall in. These pulses arrive with metronomic regularity, every 27.3 hours, varying by less than a minute. The precision suggests a mechanism, something that generates these pulses on schedule. Black holes don't have schedules. They're supremely simple objects described by just 3 parameters: mass, spin, and electric charge. Everything about a black hole's behavior follows from these properties. Nothing in black hole physics produces regular pulses with such precision. The observed timing requires a mechanism external to the black hole itself, something orbiting or interacting with it in a way that creates precisely timed energy releases. Scientists have considered orbiting objects. A star or dense gas cloud following a 27.3-hour orbit around Sagittarius A would create periodic signals as it alternately approached and receded, but no such object appears in observations. The region around the black hole has been mapped extensively. Every star near the galactic center is catalogued and tracked. Nothing orbits Sagittarius A on a 27-hour period. Whatever creates the pulses remains invisible across all wavelengths. The energy output of these pulses defies easy explanation. Each pulse releases energy equivalent to thousands of supernovae, concentrated into a burst lasting only minutes. This requires either an enormous energy reservoir that refills every 27 hours or a mechanism that can tap the black hole's rotational energy on demand. Both options demand physics we don't currently understand. Some pulses show stranger properties. They don't just release energy, they organize it. The radiation emerges in narrow beams, focused and directed rather than radiating in all directions. Natural processes usually spread energy spherically or in broad patterns shaped by magnetic fields and gas dynamics. These beams show directionality that suggests focusing mechanisms of unknown nature. The pulse's radio component carries structure, not random noise but patterns that repeat across pulses. Scientists analyzing the radio data found sequences that nearly triggered protocols for potential artificial signals. Nearly. The patterns aren't quite regular enough, don't quite follow predictable mathematical progressions, but they're too structured to be random noise. Something about the energy generation process creates organized patterns in the emitted radiation. Webb detected another anomaly near Sagittarius A. The event horizon, the boundary beyond which nothing escapes the black hole, appears to fluctuate in size. General relativity describes event horizons as fixed surfaces determined entirely by the black hole's mass and spin. These properties don't change rapidly. The horizon size should be stable, yet observations show the apparent horizon boundary shifting, expanding and contracting with a period matching the energy pulses. This shouldn't be possible. Event horizon location is not flexible. It's determined by spacetime geometry, and that geometry changes only as the black hole gains or loses mass. For the horizon to fluctuate observably, Sagittarius A would need to rapidly gain and lose significant mass fractions, but nothing is falling into or escaping from the black hole at the required rates. The mass remains stable while the horizon apparently shifts. Alternative explanations require exotic physics. Perhaps the black hole is connected to a white hole in another location, and mass cycles between them. Perhaps quantum effects near the horizon create apparent size variations as virtual particles briefly affect the gravitational field. Perhaps the black hole exists partly in higher dimensions, and its projection into our three-dimensional space varies as it rotates through those extra dimensions. All these explanations invoke physics beyond current understanding. Standard general relativity provides no mechanism for the observed behavior. Whatever is happening at the Milky Way center operates according to principles we haven't discovered. The galaxy's gravitational anchor, its central engine, is behaving in ways that challenge our comprehension of black holes, gravity, and spacetime itself. And the mysterious structure Webb detected surrounds Sagittarius A. The impossible physics, the ancient stars, the anomalous energy signatures, all concentrate near the galactic center. The black hole sits at the heart of the mystery. Whether it's causing the strange phenomena or merely affected by them remains unknown, but the correlation is clear. Whatever has transformed part of our galaxy focuses its influence around the supermassive black hole that has anchored the Milky Way for billions of years. Rogue planets in impossible orbits. Planets should orbit stars. This is fundamental astronomy. Planets form from the disk of gas and dust surrounding young stars. They sweep up material along their orbital paths. They grow massive enough to hold atmospheres. They remain gravitationally bound to their parent stars for billions of years. This process plays out around every stellar system. Planets need stars. Stars provide the gravitational anchor that keeps planets from drifting away into interstellar space. Webb found thousands of planets with no stars. These rogue planets float through the mysterious structure completely unattached to any stellar system. Not planets that were ejected from their birth systems. Those exist and we've found them before. These are different. These planets occupy impossible orbits around nothing, following paths that should require a massive central object that doesn't exist. They move as if trapped in gravitational fields with no source. The discovery came through gravitational microlensing. When a massive object passes in front of a distant star, its gravity bends the star's light, briefly magnifying it. This technique reveals dark objects too dim to see directly. Webb detected thousands of Mukralansung events in the mysterious structure region. Analysis showed these weren't stars or brown dwarfs. Their masses fall squarely in the planetary range, between half Earth's mass and 15 Jupiter masses. But their behavior violates everything we know about planetary motion. In normal space, objects follow elliptical orbits around massive bodies or drift in straight lines if unbound. These planets do neither. They orbit in closed paths without central masses. Some follow circular orbits, others trace figure-8 patterns. A few move in spirals that gradually tighten and then expand again. Every trajectory defies Newtonian mechanics and general relativity simultaneously. Track one of these planets and you see the impossible unfold in real time. The planet accelerates without apparent force. It changes direction with no gravitational influence. It maintains orbital stability around an empty point in space. Calculate the gravitational field required to produce the observed motion, and you find it requires a mass concentration that simply isn't there. The planets orbit ghost anchors, invisible masses that produce gravity without existing. Some planets move in retrograde. In normal stellar systems, planets orbit in the same direction their star rotates because they formed from the same spinning disk of material. Retrograde orbits can occur but are rare and require special formation conditions. Here, roughly half the rogue planets orbit clockwise, while the other half orbit counterclockwise around their invisible anchors. Some planets even flip their orbital direction periodically, spontaneously reversing course in ways that should require enormous energy input. The planets themselves appear normal. Spectroscopic analysis reveals familiar compositions: rocky planets with iron cores, gas giants with hydrogen atmospheres, ice worlds covered in frozen volatiles. Nothing about the planet's physical muck-up suggests exotic matter or unknown chemistry. They're ordinary planets behaving extraordinarily. Temperature measurements add more mystery. Planets without stars should be frozen, barely above absolute zero. No internal heat source can keep a planet warm for long once separated from stellar radiation. Yet these rogue planets maintain temperatures far higher than possible. Some are warmer than Earth despite receiving no sunlight. A few register temperatures suitable for liquid water. The heat has to come from somewhere, but no source exists. The orbital dynamics create stable resonances between planets. In normal stellar systems, resonances occur when planets' orbital periods form simple ratios. Jupiter's moons Ganymede, Europa, and Io orbit in a Fa-Ta-1 resonance, completing 4, 2, and 1 orbits respectively in the time it takes Jupiter to rotate. The rogue planets show similar resonances despite having no central body. They orbit in lockstep around nothing, maintaining precise mathematical relationships between their periods. Scientists initially suspected dark matter. Perhaps these planets orbit concentrations of dark matter too small to affect ordinary observations, but massive enough to provide gravitational anchors. This explains the invisible mass problem, but doesn't explain the retrograde orbits or the temperature anomalies. Dark matter should create gravitational fields indistinguishable from normal matter. It shouldn't allow planets to flip orbital directions spontaneously. Some planets show even stranger behavior. A subset orbits in vertical loops rather than horizontal circles. Imagine a Ferris wheel rather than a merry-go-round. The planets rise and fall in perfect circles perpendicular to the galactic plane. This requires gravitational fields oriented completely differently from anything we've observed in natural astrophysical systems. The distribution pattern reveals organization. The rogue planets aren't randomly scattered through the structure. They cluster in groups, concentrating at specific distances from the structure's center. These clustering distances follow a mathematical sequence, each cluster twice as far as the previous one. This geometric spacing suggests an organizing principle, something that placed or is maintaining the planets in these specific configurations. A few planetary systems show hierarchical structure. One large rogue planet sits at the center with several smaller planets orbiting it, but the central planet itself orbits an invisible point, and the entire system maintains stability despite having no gravitational anchor. It's like watching a spinning top hover in mud, defying gravity, while smaller tops orbit around it. The physics makes no sense, yet the configuration persists across months of observation. The most disturbing possibility is that these aren't naturally occurring phenomena. The precision of the orbital resonances, the geometric spacing of planetary clusters, the sustained temperatures despite no heat source, all suggest artificial maintenance. Perhaps the rogue planets aren't wandering freely, but are positioned intentionally. Perhaps the impossible orbits are maintained by technology, so advanced it manipulates gravity itself. This interpretation requires extraordinary evidence, and scientists remain cautious. But the patterns are difficult to explain through natural processes alone. When you observe precise mathematical ratios, geometric spacing, and sustained improbable conditions, you start considering possibilities beyond random physical processes. The rogue planets might be components in a vast system, objects positioned and maintained for purposes we cannot begin to imagine. Thousands of planets, impossible orbits, organized patterns, all within the mysterious structure that Webb discovered in our own galaxy. The Milky Way contains something that treats planets like particles in a design system, arranging them in configurations that violate natural law, maintaining them in states that should collapse but somehow persist. Whatever force or intelligence created this, it operates at scales and with capabilities that challenge our understanding of what's possible in the universe. Somewhere in the depths of space, a cloud of gas the size of our solar system flickers in and out of existence like a cosmic ghost. Telescopes capture it one night, find empty space the next, then detect it again weeks later in the exact same location. No known physics explains this behavior, no theory predicts it, yet instruments across the planet confirm the same impossible observation. Welcome to the Phantom Nebula, and it represents just one of 5 cosmic mysteries that shouldn't exist according to everything we know about the universe. If these phenomena intrigue you, hit that like button and subscribe. What you're about to discover will challenge the very foundations of reality itself. Picture a nebula roughly 3 light-years across, glowing with the characteristic signature of ionized hydrogen. Astronomers catalog it, measure its spectrum, calculate its mass. Then 2 weeks later they point their telescopes at the same coordinates. Nothing, empty space where a massive gas cloud should be. The nebula hasn't moved, it hasn't dispersed, it has simply vanished. Wait another month and it reappears, identical in every measurable way. Same location, same composition, same luminosity. This is the Phantom Nebula, and it defies every principle of matter and energy we've established. Gas clouds don't blink out of existence. Matter cannot simply disappear from our 3-dimensional space without leaving a trace. Yet this nebula does exactly that, cycling through visibility on a timeline that seems almost deliberate. Some physicists propose a radical explanation. What if the nebula isn't disappearing at all? What if it's moving into dimensions we cannot perceive? Extra-dimensional theory suggests that our universe might contain more than the 3 spatial dimensions we experience. These additional dimensions could be curled up, hidden at scales too small to detect, or they could be vast realms perpendicular to our reality. If the Phantom Nebula oscillates between our dimensional space and another, it would appear to vanish and reappear exactly as observed. The implications are staggering. This wouldn't just confirm extra dimensions exist. It would prove that matter can transition between them naturally. But the Phantom Nebula isn't the only cosmic mystery defying explanation. Deep within our own galaxy, radio telescopes detect bursts of energy that shouldn't exist. These aren't the famous fast radio bursts from distant galaxies. These signals originate from within the Milky Way, some less than 1,000 light-years from Earth. What makes them extraordinary isn't their power or their distance. It's their pattern. The bursts arrive in sequences, regular intervals. Specific frequencies that shift in ways that suggest mathematical structure. Natural cosmic phenomena produce random signals, chaotic emissions governed by physics but lacking organization. These bursts show organization. They repeat with timing precision that approaches 1 part in a million. They cycle through frequency ranges in patterns that appear intentional. Some signals even seem to respond to each other, as if multiple sources coordinate their transmissions. Every natural explanation fails. Pulsars create regular signals, but these bursts don't match pulsar mechanics. Magnetars produce powerful radio emissions, but not with this kind of structured pattern. Something in our cosmic neighborhood is generating organized radio signals, and we have no idea what it is or why. Now consider a region of space about 50 light-years across, where time itself appears broken. Astronomers call it the time distortion zone, though that name barely captures its strangeness. Within this region, stars show impossible age differences. 2 stars sit side by side, separated by less than a light-year, both formed from the same molecular cloud, born from the same cosmic material at the same moment. Standard stellar evolution says they should be the same age, progressing through identical life stages. Yet measurements reveal one star is 3 billion years older than its twin, not appeared older due to some optical effect. Actually older, with internal structure and chemical composition matching a star that has burned for billions of years longer than physically possible. The time distortion zone contains dozens of such paradoxes. Young stars that should be ancient. Ancient stars that appear newborn. Light from these stars arrives carrying spectral signatures from different epochs, as if time flows at different rates depending on precise location within the zone. This suggests something profound and terrifying. Spacetime itself might not be uniform. The fabric of reality could contain wrinkles, regions where temporal flow differs from surrounding space. These aren't black holes or gravitational anomalies. The stars in the time distortion zone follow normal orbital mechanics. They emit normal radiation. Only their ages refuse to make sense. Strange stellar behavior extends beyond the time distortion zone. Across the galaxy, astronomers have catalogued star clusters where every star blinks in perfect synchronization. not the regular pulsation of variable stars, which follows internal physics. These stars brighten and dim together, hundreds of individual stellar bodies acting as a single coordinated entity. The synchronization is perfect across light years of distance. Stars on opposite sides of a cluster dim simultaneously, despite being separated by distances that light takes years to cross. No signal could coordinate their behavior, no known force acts fast enough, yet they pulse as one, as if connected by something that transcends space itself. Some clusters show even stranger patterns. Stars that shouldn't vary in brightness suddenly begin oscillating. Giant stars, stable for billions of years, suddenly develop rhythmic brightness changes with no physical cause. Entire stellar populations shifting their output in patterns that suggest response to external influence. The stars themselves show no internal changes, no mass loss, no temperature fluctuations, nothing that would cause brightness variation. Yet they dim and brighten on schedules that imply purpose. Finally, consider the invisible mass problem, not dark matter, which we understand reasonably well through gravitational effects. This is something else entirely, something that shouldn't exist within current physics. Certain galaxies show gravitational influences indicating massive objects, things with billions of solar masses pulling on visible matter. But these masses are completely invisible, not dark, invisible. They emit no radiation at any wavelength. They don't block light from background sources. They don't create gravitational lensing effects, yet their gravitational pull on surrounding matter is undeniable, measurable, impossible to ignore. These aren't black holes. Black holes create distinctive signatures, warping spacetime in ways we can detect. These objects produce gravity without any of the associated effects. They pull on stars and gas clouds with immense force while remaining completely undetectable except through that gravitational influence. Some masses seem to move through galaxies like cosmic phantoms, their presence revealed only by the spiral wake of disturbed matter they leave behind. Whatever these objects are, they interact with normal matter through gravity alone, ignoring every other fundamental force. They represent a form of mass that exists outside our standard model of physics, objects that shouldn't be possible yet clearly are. 5 mysteries, 5 impossible observations. Each one confirmed by multiple independent instruments, each one lacking any conventional explanation. Together, they suggest our understanding of the cosmos remains fundamentally incomplete. Empty space isn't empty. Astronomers have known this for decades, understanding that the vacuum of space contains quantum fluctuations, virtual particles, and the faint whisper of the cosmic microwave background. But something else lurks in the cosmic voids, the vast empty regions between galaxy superclusters that should contain essentially nothing. Instruments detect energy signatures emerging from these voids, readings that suggest organized activity in regions where no matter exists. The universe is hiding something in plain sight, concealed within the very emptiness we thought we understood. If this revelation captivates you, hit that like button and subscribe. What follows will overturn everything you thought you knew about cosmic structure and scientific certainty itself. Cosmic voids span hundreds of millions of light years, regions so empty that entire galaxy superclusters could fit inside them with room to spare. Standard cosmology predicts these voids should be nearly devoid of matter and energy, containing perhaps a few stray atoms per cubic meter and nothing else. Yet deep surveys of these regions reveal something extraordinary: energy readings. Not the background radiation that permeates all of space, but specific, localized emissions that appear and disappear on timescales ranging from hours to months. Some voids show periodic bursts of gamma rays with no visible source. Others emit radio signals that sweep through frequency ranges in organized patterns. A few produce gravitational wave signatures that suggest massive objects accelerating, yet no objects appear in any wavelength of light. The voids aren't empty, they're active. Something exists within these regions, something that produces energy without revealing its nature. The universe has been hiding phenomena in the one place we assumed nothing could hide, within the cosmic emptiness between everything else. When the first observations emerged, the scientific community responded exactly as you'd expect. Skepticism, outright denial from some quarters, accusations of instrument malfunction, data processing errors, misinterpretation of background noise. Senior astronomers dismissed the findings as artifacts, convinced that decades of established cosmology couldn't be overturned by anomalous readings from supposedly empty space. But then other telescopes confirmed the observations. Independent teams using different instruments on different continents detected the same energy signatures in the same cosmic voids. Radio telescopes in Australia confirmed gamma ray detections from satellites in orbit. Ground-based observatories verified gravitational wave readings from space-based detectors. The pattern became undeniable. Something real was happening in the cosmic voids, and it didn't match any known physics. Scientific conferences that normally discuss incremental refinements to existing theories suddenly convened emergency sessions to address observations that threatened fundamental principles. Research initiatives launched across the globe, coordinating observation campaigns to monitor cosmic voids continuously. The initial skepticism transformed into urgent investigation as the weight of evidence became overwhelming. This verification crisis sparked an explosion of alternative theories, each attempting to explain observations that standard physics cannot accommodate. Modified gravity theories, long relegated to the fringes of cosmology, suddenly gained mainstream traction. What if gravity doesn't work exactly as general relativity predicts at the largest scales? What if the cosmic voids reveal deviations from Einstein's equations that only manifest in regions of extremely low matter density? These theories propose that empty space itself possesses properties we've never detected, characteristics that become apparent only when normal matter is almost entirely absent. Other physicists explore even more radical possibilities. Parallel universe intersection theories suggest that cosmic voids might represent regions where our universe comes into close proximity with other dimensional spaces. The energy signatures could be leakage from adjacent realities, breakthrough points where the membrane separating universes becomes thin enough for effects to cross over. Some theoretical frameworks propose that reality itself has a fabric with detectable structure, and cosmic voids allow us to perceive this fabric directly, unobscured by the presence of matter and energy. Every proposed explanation requires abandoning some aspect of conventional physics. Every theory demands that we reconsider fundamental assumptions about how the universe operates. But these aren't just abstract theoretical concerns. These mysteries have direct implications for Earth and our understanding of our cosmic position. We orbit a star in a galaxy we thought we understood, following physics we believed were settled science. Now we discover our galaxy might harbor invisible masses, phantom nebulae that phase in and out of our dimensional space, synchronized stellar behaviors that suggest unknown forces at work. Our position in this galaxy suddenly becomes less certain. We don't know what else might be hidden around us, what other phenomena might affect our local cosmic neighborhood. Consider the potential risks we never contemplated. If massive objects can exist without revealing themselves through any radiation, how many might pass near our solar system undetected? If time itself flows differently in certain regions of space, what happens to spacecraft that enter those zones? If stars can synchronize their behavior through unknown mechanisms, what other coordinated cosmic events might occur without warning? These mysteries don't just challenge our theories. They reveal gaps in our awareness of immediate cosmic surroundings. Every assumption about the stability and predictability of our galactic environment now requires re-examination. Yet these discoveries also present unprecedented opportunities. New physics means new technologies. Understanding the mechanisms behind phantom nebulae could unlock manipulation of dimensional boundaries. Decoding the synchronized stellar behavior might reveal communication methods that transcend light speed limitations. Identifying the invisible masses could expose entirely new states of matter with revolutionary applications. The larger implications extend far beyond our galaxy or even our cosmic neighborhood. Physics textbooks at every level, from high school introductions to graduate-level quantum field theory, require revision. The standard model of particle physics, general relativity, cosmological principles, all face challenges from observations that don't fit established frameworks. This isn't incremental refinement of existing theories. This is fundamental restructuring of how we understand reality. And here's what makes this even more profound. If our galaxy contains these mysteries, every galaxy likely harbors similar phenomena. The phantom nebula, the unexplained radio bursts, the time distortion zone, the synchronized stars, the invisible masses, the active cosmic voids, none of these are unique to our cosmic location. Statistical probability suggests that every galaxy in the observable universe experiences comparable mysteries. We've detected these phenomena only because we've finally developed instruments sensitive enough and observation programs systematic enough to notice. How many other cosmic mysteries remain undetected, hiding in data we haven't analyzed carefully enough or in wavelengths we haven't monitored comprehensively? The universe reveals itself as stranger than we imagined, more complex than our theories predicted, more mysterious than our equations capture. Every answer generates new questions. Every explanation reveals deeper puzzles. We stand at the threshold of a revolution in cosmic understanding, armed with observations that demand we abandon comfortable assumptions and embrace the profound strangeness of reality itself. The cosmos has been keeping secrets, and we're only beginning to uncover them. Every answer breeds a dozen new questions, and right now we're drowning in questions. What is the true nature of the phenomena emerging from cosmic voids? Not theories or speculations, but actual mechanisms. What physical processes allow a nebula to phase between dimensions? What force synchronizes stars across light years of space with perfect precision? These aren't rhetorical questions pondered in late-night philosophical discussions. These are urgent scientific inquiries that demand answers, yet every investigation reveals deeper mysteries. Consider the timeline. How long have these phenomena existed? The Phantom Nebula didn't suddenly appear last year. The synchronized stars have been pulsing in unison for how long? Centuries, millennia, since their formation billions of years ago. If these mysteries have always been present, why are we only discovering them now? Have our instruments finally reached sufficient sensitivity, or has something changed in the cosmos itself, activating phenomena that remain dormant for eons? And here's the question that should unsettle you most. What else are we missing in our own cosmic backyard? We've detected phantom nebulae, unexplained radio bursts, time distortion zones, invisible masses, and active cosmic voids. These discoveries emerged not from the distant universe, but from our galactic neighborhood, some within a few thousand light years of Earth. If we missed these phenomena for so long, what else lurks undetected in nearby space? What other mysteries hide in regions we thought we understood completely? The scientific community isn't waiting for answers to arrive on their own. Observation campaigns are being planned and executed at unprecedented scale and coordination. The James Webb Space Telescope, already revolutionizing our understanding of the early universe, is now dedicating significant observation time to these local mysteries. Extended schedules target the Phantom Nebula, attempting to capture the exact moment of its dimensional transition. Infrared sensors monitor the time distortion zone continuously, searching for spatial signatures that might explain impossible stellar ages. Webb's unprecedented resolution and sensitivity offer possibilities previous instruments couldn't achieve: the ability to detect subtle variations in spacetime structure, to capture spectral signatures from objects that barely interact with normal matter, to observe phenomena at wavelengths where cosmic mysteries might reveal themselves most clearly. But Webb doesn't work alone. Ground-based telescopes across the planet coordinate their observations, creating a comprehensive monitoring network that never sleeps. Radio telescope arrays track the unexplained bursts, triangulating their sources with increasing precision. Optical observatories watch synchronized star clusters, measuring their coordinated behavior across multiple wavelengths simultaneously. Gravitational wave detectors remain alert for signatures of invisible masses moving through nearby space. This coordinated effort represents the largest systematic study of local cosmic anomalies ever attempted. Scientists hope to learn not just what these phenomena are, but why they exist at all. Does the Phantom Nebula's behavior reveal fundamental properties of extra dimensions? Can the synchronized stars teach us about forces or fields we've never detected? Will the time distortion zone expose flaws in our understanding of relativity itself? Every observation brings new data, but data alone doesn't provide understanding. The real goal is comprehension, a framework that explains these mysteries within a coherent physical theory. Yet even as observation campaigns proceed and data accumulates, we must confront an uncomfortable truth. We live in a galaxy we're only beginning to understand. The Milky Way, our home for as long as humanity has existed, contains secrets we never suspected. For centuries, we gazed outward toward distant galaxies, exotic quasars, and remote cosmic structures, assuming that the most interesting phenomena existed far away in extreme environments. We studied black holes at galaxy centers billions of light years distant. We investigated the earliest moments of cosmic history through light that traveled for over 13 billion years. We looked to the edges of the observable universe for answers to fundamental questions. And all the while, some of the most profound mysteries waited right here in our local cosmic neighborhood. The most profound discoveries don't always require looking to the farthest reaches of space. Sometimes they hide in regions we thought were mundane, in the spaces between familiar stars, in the voids we assumed were empty, in the stellar behaviors we considered fully explained. The Phantom Nebula sits less than 5,000 light-years away. The unexplained radio bursts originate from within our own galactic spiral arm. The synchronized star clusters exist in regions we've mapped and catalogued for decades. These aren't exotic phenomena from the distant universe. These are local mysteries, cosmic anomalies occurring in our immediate galactic environment. This proximity makes the discoveries more immediate and more unsettling. We cannot dismiss these phenomena as irrelevant distant curiosities. They exist in our cosmic neighborhood, potentially affecting conditions around our own solar system. Think about what this means for human understanding. Every civilization that gazed at the night sky, every ancient astronomer who tracked the stars, every modern scientist who studied galactic structure, all of them looked at a galaxy hiding profound secrets. The Milky Way wasn't fully revealing itself. The cosmos kept mysteries tucked away in plain sight, waiting for the right instruments and the right questions to expose them. We developed increasingly sophisticated theories about cosmic structure, dark matter distribution, stellar evolution, galactic dynamics. We built mathematical frameworks describing how galaxies form and evolve. We created simulations modeling cosmic history from the Big Bang to the present. And throughout this entire intellectual journey, phenomena existed around us that our theories couldn't predict and our frameworks couldn't explain. The universe's greatest secrets might be right here in the Milky Way, not scattered across billions of light years in remote galaxies, but surrounding us in our local cosmic space. The synchronized stars pulsing in perfect harmony, the invisible masses pulling on visible matter, the nebula phasing between dimensional spaces, the voids that aren't empty, the regions where time itself flows differently. These mysteries don't require billion-dollar space telescopes pointed at the edge of the observable universe. They require careful, systematic observation of our own galactic neighborhood, combined with willingness to question assumptions we thought were settled. We stand at a threshold moment in cosmic understanding. The observations are undeniable, the mysteries are real, the implications are profound. What we do with this knowledge, how we respond to discoveries that overturn comfortable certainties, will define the next era of astronomy and physics. The universe has shown us that we understand far less than we believed. Our galaxy holds secrets we're only beginning to uncover, and the greatest cosmic mysteries might be closer than we ever imagined, hiding in the space between stars we thought we knew completely. The question isn't whether more mysteries await discovery. The question is whether we're ready to find them.